Thank you for being part of Dr. Emanuel's presentation on triple integrals. Part 2, this is lecture number 16 in 2008. We went through the theory of triple integrals, of what order to perform these integrals. Inner, then you go to the outer, the dz, then the dy, then the dx. We talked about how do we determine the limits on these, each of these, where z1 is a function of x and y, z2 is a function of x and y. And when x is a function of y, and then we saw that we have our constants here for our x1 and our x2. So we're going to see with this cubed, what is the triple integral and what are the limits for this particular cube. Remember, we have to take dx, dy to give us that area. Then we're going to go dz, and that's just nothing but a cube now. And we're just going to keep adding cube from 0, from z equals 0 to z equals what? 2. So we should see that z equals from 0 to 2, that y goes from 0 to 2, and that x goes from 0 to 3. So, yes, what do we see here? The first one we were going to do is dz, okay, from 0 to 2, as you can see here. dy as we go from 0 to 2, and dx as we go from 0 to 3. So, we take the integral of dz, which is just 1, then we're just going to get what? Z. And then the first limit is 2, and the second limit is 0. So that's all we're going to have is just 2. So then we're going to have 2 dy, and then the same thing we're going to do here. And we see that if you take the derivative of dy, 2 dy, you're going to get what? 2y. And we're going to take the limit from 0 to what? To 2. So if we plug in 2 here for y, plug in 0, that goes out. That gives us what? 4. Okay, so now that we have 4, we're going to take the derivative, the integral of 4 dx, and we should get just 4x. And then we're going to take it from 0 to 3. The 0 goes out, the lower limit, and we have what? Put in 3 here, we get 12. So here we see that our volume is equal to what? 12. We can also calculate it another way. Length times width times height. What is the length times the width is 6. 2 times 3 is 6. Times 2 is 12. There we go. So I hope this is making sense to you. Now we're going to start doing spheres. We're going to start doing, we got a, not spheres. We have a cube here. We're going to be bounding these by planes now. Okay. Example 2, we're going to be dealing with planes. Ah, look. Here we have a plane. An upper plane, z equals 1 plus y, and a lower plane, 2 equals 2xy. And we got corners. Okay, so we're going to have boundary points on this. We have corners. This corner here is 0, 0. This one goes up to what? 1. Okay, this corner here goes up to 1. This corner here goes over to 2. This corner here goes over to 3. So we have all of these things that we need to take into consideration. Find the volume of the object shown below using triple integration. Yes. Okay, so we said we have boundary planes. Okay, we have 0, 0, 0. Here we go. We have upper plane, which is z equals to y plus 1. We have a lower plane where 2 equals 2x plus y, or 2x plus y equals 2. So that's our bounding planes. Now, what about our bounding points? We talked about them earlier. Okay, at y equal to 0, we're going to plug that into our upper equation. We plug in y equal to 0, we get z equals 1. So if we look here on this plane, we have y equals what? 0, z equals 1. All right, that's good. Now we want to find out what happens to the lower plane. Okay, if we use the lower plane and we plug in y here, we get 2x equals 2 and x equals what? 1. So let's see if that's true. When y equals 0, x equals 1. There it is. So we found out these 2 points. Let's make sure we keep a track of what points we find and have found and how we are bounded. Okay, when x equals 0, what happens? In our lower plane, because we don't have an x in the upper plane. In the lower plane, we have y equals 2. So now when we have x equals 0, what do we have? Y equals 2. Okay, how to get the corners? Okay, now what we want to do is we want to plug in for, we see that y equals what? 2. So when y equals 2, we plug that into our upper equation because we did already the lower equation. Now we want to find the upper equation. So as we look at the upper equation, we plug in 2. So then we get z equals 1 plus 2, which equals 3. There it is. So when y is 2, z is 3. Okay, so we have all of these points that we have to remember and utilize them. Okay. Find the volume where we first perform z dz, then y dz, then x dz. Now notice we are saying what order we're going to read these in. So we have dz, down inner, and dz is going from z1 depending on as a function of x and y. And it's going to z2 as a function of x and y. dy is a function of x only, dy1 and dy2 is a function of x, and then we're going to have x1 and x2. And we looked at all of this already, so let's keep going. Now, where are our boundaries? What did we say they were? Review. We have here at z1 is going to start at what? 0. And where is it going to? It's going up to this curve here. Okay? Y, 1 plus y. What about y? Y is doing the same thing. Y is starting at what? 0. And it's going to where? It's following this lower equation. Okay, so if you see this is the lower equation, we see that y is equal to what? Bring this to the other side. 2 minus 2x. Now what about x? X is going from what? 0 to 1. All right, so now we have all of our boundaries. And let's plug them in. All right, so let's look at this one here. The one that we want to look at first is the inner. And so we have our dx from 0 to 1, our y from x from 0 to 1, our y from 0 to 2 minus 2x, our z from 0 to 1 plus y. Okay, so now if we plug this in, we get z, and so the lower limit is going to drop out, and all we're going to be left with is 1 plus y dy. Okay, now when we do this one, we see that what we have is, what is the integral of 1? Is y. What's the integral of y? 1/2 y squared. So this quantity, we're going to evaluate them at 2 minus 2x, our upper limit, and then 0 at our lower limit. So as you know, at our lower limit, it's just going to drop out. So all we have here is that we're just multiplying this times this here. We're plugging it in. here. We'll plug in for y, 2 minus 2x. That's where the y is. Then we have a 1/2 times 2 minus 2x squared dx. Okay, let's go to the next page and we'll bring that equation back up so that we can know where to start. Okay, we're starting here again. This is where we ended. Okay, so now what we're going to do is we're going to integrate this in reference to what? Before we integrate it, what we're going to do is we can integrate it, but before we can integrate it, we need to bring like terms together. So we're going to multiply this out. We just bring this down and we keep the 1/2 out there. And when we multiply this out, we get 2 times 2 is 4. Okay, 2 times 2x. And we get 2 of them, so we get a minus 8x. And then we have a 2x squared. So that's a 4x squared. Okay, so now that we have this equation, now we can combine these equations together. Okay, so if we look at our x squared, we take half of 2. What do we get? A 4. We get 2. Okay, we have our 2 here. So if we subtract, we get 1/2. So we have 6x minus 2x. Sorry, we have 8 minus 2x. So if you take half of 8, you get 4. So it's a minus. So 4 minus 4 plus a minus 2 gives us a minus 6. We have here our 4. We have half of 4 is 2. 2 plus 2 is 4. So this is what we're going to integrate. Okay? So now for our integration, what we're going to do is x to the third power, 2 times x to the third power. We bring that to the third power, so we're going to keep the 2, the constant out front. It's raised to the third power divided by 1/3. The minus sign stays. And we take this is going to be raised to the x squared to the 1/2. So 1/2 of 6 is what? 3. X squared. And then we just have 4. So that'll be 4x. Then we're going to plug in the values for what? 0 to 1. Okay, if we plug in 0, that goes out. If we plug in 1 here, 1 cubed is still 1. Okay, so it's 2/3. 1 squared is still 1. So it's a minus 3. And then 1 times 4 is 4, and the other ones go all to 0. So now what we do is we got to find our common denominator, which is going to be 3. So we keep the 2/3 there. We multiply 3 times 3 over 3. We multiply 4 times 3 over 3. And what we get is 2 minus 9. 3 times 3 is 9. 4 times 3 is 12. And we get 5 divided by 3. Okay, so this is our volume. Okay, so we're going to do one more example, and what we're going to do is we're going to change the order, and we're going to see if we can still come up with 5/3. Okay, so this is part 2. It's done, and we'll be going to part 3. So you can concentrate on it. It's been around 14-15 minutes. They said every 10 minutes you should give you guys a break. So we're going to give you a break at this time. Thank you.